picture this like prompt injection is a hacker's treasure chest. It hands them the key to manipulate AI and large language model systems. They can sneak past security gates, exploit weak points, and even breach fortified defenses as well. How large language models behave. They craft input prompts that led AI models astray. By injecting these kind of specific instructions, they puppeteer these models to produce responses that they shouldn't. It's like whispering a secret code to AI, how far enough capabilities they have, like how they are able to stand against the prompt injection attacks in different scenarios, starting from prompt only situations in conversation, along with some other examples that are mentioned in the comparison chart as well. Assalamu alaikum everyone. Hope you all are doing well. So before we moving forward, let's discuss some points regarding the previous lectures about the prompt engineering course articles. Start from crafting strategies to the advanced level techniques. All are included and discussed with details properly in the previous lectures. So for now, we are moving towards the dark side of our large language models. As on already basis, we try to learn how to create an accurate prompt. Now we are about to learn the injection methodologies that will be utilized in prompts to inject malicious inputs in large language models to capture or hijack a conversation logs and responses and try to gather some information out of it. So let's move forward. For prerequisites, you will need a firm grasp on prompt engineering, a familiarity with pre-trained large language models like GPT-3, BERT, and T5, and a basic understanding of NLP and machine learning. After that, we will discuss our goals, like what will be our objectives. We'll try to get an insider's peek into prompt engineering, prompt injection techniques, and learn like why they're crucial for LLMs. Then we will try to reveal the secrets of how attackers exploit these vulnerabilities. After that, we will learn about different flavors of prompt injections. Then we then we will try to understand the privacy concerns regarding the real world scenarios of prompt injection vulnerabilities. All right, so here is the roadmap like agenda for our adventure into the dark side of LLMs, as you can see through the example picture mentioned in that slide as well, where where a malicious prompt is tried to inject into the large language models and try to generate some malicious output out of it. So now, welcome back to the heart of darkness, where vulnerabilities in large language models lure. Prompt injection is a clever technique in prompt engineering for large language models. It involves embedding a specific instruction or questions directly within the text, guiding the model to generate desired responses by strategically placing prompts. So we can harness the power of LLMs more effectively for various tasks, by making them a valuable tool for natural language processing. It's all about embedding tricky instructions into input prompts that mess up with the model's responses. So this technique is like a cunning infiltrator that tries to disturb the trustworthiness of these models. Think of it like the AI version of whispering secrets to a friend that make them do something unexpected out of this whole scenario. So now, why should you even care about this dark art? Well, picture this like prompt injection is a hacker's treasure chest. It hands them the key to manipulate AI and large language model systems. They can sneak past security gates, exploit weak points, and even breach fortified defenses as well. This technique is like a hacker's blueprint to play puppet master with AI systems. So it's not just about understanding, but also you try to defend against this digital dark side as well. As you can see through the possible prompt injection methodology mentioned in the diagram as well, along with the scenario where an attacker try to inject the malicious input to the large language models through different question scenarios like how to inject, what is the operational impact, what is the informational impact, are also how it can be targeted. Yeah, like what kind of user, what kind of person will be affected through this type of scenarios. All right, let's delve into the arena of prompt injection techniques. Imagine it as a box of tools where ingredient is a type that differs based on its different purposes. Starting from string-based prompt injection, trick AI by injecting malicious, like we have to trick AI by injecting malicious strings. Then we have some code-based prompt injection. Like there, we have to sneak some code-specific snippets into prompts for secret injections, for secret actions, injections, and something else. Then we have some contextual prompt injection. Like there, we have to twist AI responses by playing with context, not with the prompt, not with some other conversation, responses, questions, each and everything, but with the context behind the prompt injection. Then we have some knowledge-based prompt injection techniques. There we will try to shape outcomes using your domain knowledge. Then hybrid prompting, every time when we try to consider hybrid approach, we will try to mix and match techniques for advanced manipulation techniques. Now it's showtime for the attacker. Imagine it like an attacker is armed with the insights of large language models, like how large language models behave. They craft input prompts that led AI models astray. By injecting these kind of specific instructions, they puppeteer these models to produce responses that they shouldn't. It's like whispering a secret code to AI that makes it do your bidding, even if it's not supposed to. As you can see through the example that is given, that is taken from ChatGPT as well, where where a user tried to inject some malicious queries regarding SQL injection attack vector in large language model. And eventually, large language model is tried to apply that particular malicious payload or query against a vulnerable platform and try to generate some output through it. So overall, this whole example will able to tell us that we are able to inject some malicious query from the mutated payloads from that are generated by the large language models as well. Now we are moving towards the privacy concerns regarding the prompt injection in real world scenarios, like how to avoid these kind of vulnerabilities in the fine tuning and customization based sessions of LLMs. Like we already discussed about their details in previous lectures, but the shadows run deeper. Even beyond our thought process. That means the privacy is on the front line here. So we can have so we need to have to protect the sensitive info into in large language models, like starting from a wide sensitive information exposure. Like we have to keep AI away from spilling secrets. Then we have some user consent and anonymization. It's like we have to anonymize data to keep individuals hidden. Then some encryption mechanism, like we know in cryptography, in crypto, in security domain, encryption plays an important role. Like we have to lock data within prompts to prevent attacks, prevent leakage of data through man in the middle attack or something, someone like those type of attack that directly impact the hidden input of our data. Then we have some contextual restrictions, like we try to set some boundaries on what data AI can access through these type of prompts. Now let's time. No, it's time to look at the comparison between the different types of large language models and how far enough capabilities they have, like how they are able to stand against the prompt injection attacks in different scenarios, starting from prompt only situations in conversation, along with some other examples that are mentioned in the comparison chart as well. It's like we are watching AI superheroes facing off against cunning villains. And also you can see through the diagram as well, which show different type of variety of LLM large language models in terms of different scenarios. But remember, every time the darkness come with challenges. So starting from model sensitivity, AI's here trigger responses to specific prompts response and prompts. And then we have some contextual complexity, where we have some contextual responses, contextual efficiency data. In previous strategies, we also face some complexity by navigating AI's intricate understanding of context. Then we have unintended consequences like AI take a wrong turn and producing a base outputs. Then we have some privacy concerns and security, the looming threat of exposing sensitive data. Then detection difficulty, obviously by spotting malicious prompts, admits that legitimate data is leak out through these type of scenarios. Then we have some model limits, like AI is hitting a roadblock in grasping complex forms. Then we have some adversarial nature-based injection attacks, the ongoing chess match between attackers and defenders. In the midst of this type of darkness, there is a glimmer of light, like prompt injection, when harnessed for good empowers user. It will empower the user to shape AI responses like according to their needs. By injecting precise prompts, we guide large language models to provide accurate and relevant content. It's like training. We are trying to train an AI friend to understand you better. Prompt injection spans understanding, spans industries, making AI more initiative and interactive. And the journey doesn't end here. So continued teamwork between researchers, developers, and experts will drive prompt injections potential even further. We are turning darkness into a force for good in the real world scenarios in AI. So that's all from my side regarding prompt injection. Thank you.